Somebody is ಹೇಳ್ತಾ ಇಲ್ವಾ ನಾನು ಜಾಯಿನ್ ಆಗಬೇಕಾದ್ರೆ ಮೊದಲೇ ಜಾಯಿನ್ ಆಗಬೇಕಂತ. Again and again if you are start disturbing, it is difficult to engage the class. Okay, so now does the screen is visible for you now?
Yes, sir.
Screen ಕಾಣ್ತಾ ಇದೆಯಾ? We are going to discuss about these things: angular measurements, bevel protractor and sine bar. So what do you mean by an angle? Angle ಅಂದ್ರೆ ಏನು? ಫಸ್ಟ್ ಹೋಗೋದಕ್ಕೆ ಮೊದಲು ನಾವು angle ಅಂದ್ರೆ ಗೊತ್ತಿರಬೇಕು ನಮಗೆ. So for example, these are the two lines. These are the two lines meeting at one point. ಯಾವ್ದಾದ್ರು ಒಂದು ಪಾಯಿಂಟ್ ಹತ್ರ ಮೀಟ್ ಆಗ್ತವೆ. ಸೊ ಆಂಗಲ್ ಸಬ್ಟೆಂಡೆಡ್ ಫ್ರಮ್ ದಿಸ್ ಪಾಯಿಂಟ್, ಈ ಪಾಯಿಂಟ್ ಇಂದ ಏನಾಗಿದೆ, ಇಲ್ಲೊಂದು ಲೈನ್ ಹೋಗಿದೆ, ಇಲ್ಲೊಂದು ಹೋಗಿದೆ. ದಿಸ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಅನ್ ಆಂಗಲ್. Opening between two lines which meet at a point, this is called an angle. I am going to represent this angle as theta ಅಂತ ಕರೆದುಬಿಡ್ತೀನಿ. So angles are measured in degrees. ಯಾವ್ದ್ರ ಮೆಜರ್ ಮಾಡ್ತೀವಿ ನಾವು? ಡಿಗ್ರೀಸ್ ಮೆಜರ್ ಮಾಡ್ತೀವಿ. So if I take degrees ಅಂದ್ರೆ ಹೆಂಗಪ್ಪ ಅಂದ್ರೆ, for example, if this is a circle, I will go back, I will take so I am going to take one circle. So this circle is going to be divided into number of parts. Number of parts in the sense 360 parts. I am going to divide it into how many parts? Like that, I am going to divide into 360 parts. These are not 360. So imagine ಮಾಡ್ಕೊಡ್ರಿ, these are how many? 360 parts. Each part is called as what? 1 degree. Each part is called as what? 1 degree. If I divide a circle into 360 parts, then each part is called as what? 1 degree. Each part is called as what? 1 degree. So again this 1 degree, so this is a circle. So this circle is divided into 360 part. Divide into 360 parts, and each part is called 1 degree. Again this 1 degree, for example 1 degree is bantu that got one part. This is one part is 1 degree. Again this part is divided into 60 parts. Just observe this one. How much? Each degree is divided into 60 minutes, and each minute is called as what? 60 seconds. So again this degree, 1 degree is divided into 60 minutes. 1 degree is divided into 60 minutes, and 60 minutes, 1 minute is divided into 60 seconds. So generally degree is represented by 1 degree 0, minute is represented by 1 dash, seconds is represented by double dash. Okay, so this is the what you mean by angle. So radians ಅಂತ ನೀವು ಬರೀತಾ ಇರ್ತಾರೆ, ನಿಮ್ಮ ಇದರಲ್ಲೆಲ್ಲ ರೇಡಿಯನ್ಸ್ ಅಂತ ಇರುತ್ತೆ, ನೀವು ಅಬ್ಸರ್ವ್ ಮಾಡಿರ್ಬೋದು. ವಾಟ್ ಯು ಮೀನ್ ಬೈ ರೇಡಿಯನ್ಸ್? So if this is a circle, I am going to take one more circle over here. So let us take, this is the center of the circle, this is the radius. Let us this O and name it as A, and let us take this as B. So AOB, angle AOB is the angle. It is called as what? Angle. So let us take OA is equal to 5 centimeter. OA is equal to 5 centimeters. The angle subtended by an arc, the angle subtended by an arc. Arc is what? AOB. This is the arc. Okay. So if this arc AB is equal to radius OA, then it is called 1 radian. Then it is called as what? 1 radian. ಸೊ ಈ ಸಬ್ಟೆಂಡೆಡ್ ಆರ್ಕ್ ಇದೆಯಲ್ಲ, ಇದು ಈ ರೇಡಿಯಸ್ಗೆ ಈಕ್ವಲ್ ಆದರೆ ದೆನ್ ಇಟ್ಸ್ ಕಾಲ್ಡ್ ಆಸ್ ವಾಟ್? 1 ರೇಡಿಯನ್ಸ್. It's called as what? 1 radians. So unit of angle derived from theoretical consideration is the radian. So theoretically what we are going to derive is called as what? A radian, defined as the angle subtended at the center of a circle by an arc length equal to the radius of the circle. So radian means what? This is an arc subtended by the arc of a circle. ಈ ಲೆಂತ್ ಎಷ್ಟಕ್ಕೆ ಈಕ್ವಲ್ ಆಗುತ್ತೆ ಅಂದ್ರೆ OA ಗೆ ಈಕ್ವಲ್ ಆದರೆ then it is called as what? 1 radian. So next, how to measure the angles? What are the instruments available for measuring the angles? So line standard angular measuring devices, we have protractors are there that you have seen right from the high school level itself, how to measure the angles. So in coming to the technical level, you are going to measure by using universal bevel protractors. This is for your syllabus and we are going to study this one. Next one is phase standard angular measuring devices, sine bar, another one is a sine center. So main important thing, take the question, what do you mean by line standard? What do you mean by phase standard? What do you mean by line ends? Take the question, line ends, and what do you mean by phase ends? Question totally, I am going to ask the question for tomorrow. What do you mean by line ends and what do you mean by phase ends? So measurement of inclines. Tomorrow question na? Hello?
Yes, sir. Totally.
Yes, what do you mean by line ends and what do you mean by face ends? Okay, measurement of inclines. Inclinations irutte. So generally for inclinations levels ke spirit level use ಮಾಡ್ತೀವಿ. Another one is the clinometer use ಮಾಡ್ತೀವಿ. Angle comparators, autocollimators we are going to use. So these are all the devices we are going to use for the measurement of angles. So for your syllabus, only bevel protractors and sine bars are there, and we are going to discuss in today's class that much only. So this is an overview of the pictorial diagram of bevel protractor. So these are the parts. So this is an adjustable blade. This is an adjustable blade. This is acute angle attachment. This is base plate. This is a vernier scale, and this is one main scale. There are two scales. Every instrument. If you go for vernier scale, there are two scales. If you come for screw gauge, there are also two scales. One is main scale, another one is a circular scale. If you come for vernier scale also, there is one is vernier scale, another one is a main scale. If you come for bevel protractor also, there are two scales. One is a main scale, another one is a vernier scale. Every instrument has its own least count. So this is main scale, this is a main scale, and this is a vernier scale. So in generally in your exam they are going to ask, write a neat sketch of bevel protractor and explain its function in ಕೇಳ್ತಾರೆ. Write a neat sketch of bevel protractor and explain its functions and how it is going to be used ಅಂತ ಕೇಳ್ತಾರೆ. So this is a bevel protractor. So this is a blade. This is called as what? Adjustable blade. We are going to call it as what? Adjustable blade. Adjustable blade ಅಂತ ಯಾಕೆ ಕರಿತೀವಿ ಅಂದ್ರೆ this can be moved to and fro. ಇದನ್ನ ಏನು ಮಾಡಬಹುದು, ಈ ಕಡೆ ಮೂವ್ ಮಾಡಬಹುದು ನಾವು. We can move like this. We can move like this. ಹಿಂದೆ ಮುಂದೆ ಇದನ್ನ ದಿಸ್ ಇಸ್ ಎ ಗ್ಯಾಪ್ ನೋಡ್ರಿ, ಮೂವ್ ಮಾಡಕ್ಕೆ ಏನ್ ಮಾಡಿದ್ದಾರೆ, ಒಂದು ಸ್ಲಾಟ್ ಕೊಟ್ಟಿದ್ದಾರೆ. ಈ ಸ್ಲಾಟ್ ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, ಈ ಬ್ಲೇಡ್ ಏನಾಗುತ್ತೆ ಮೂವ್ ಮಾಡಬಹುದು. ದಿಸ್ ಇಸ್ ಎ ನಟ್, ಬ್ಲೇಡ್ ಲಾಕಿಂಗ್ ನಟ್. ಸೊ ಎಲ್ಲಿ ಯಾವ ಜಾಗಕ್ಕೆ ಹೋಗಿ ಆ ಜಾಗಕ್ಕೆ ಮೂವ್ ಮಾಡಿಕೊಂಡು ಇದನ್ನ ಏನ್ ಮಾಡ್ತೀವಿ ನಾವು, ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಲಾಕ್ ದಿಸ್ ನಟ್ ಸೊ ದಟ್ ಇಟ್ ವಿಲ್ ಬಿ ಫಿಕ್ಸ್ಡ್. ಸೊ ದಿಸ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ ವಾಟ್? ಅಡ್ಜಸ್ಟಬಲ್ ಬ್ಲೇಡ್. ಸೊ ಅನದರ್ ಒನ್ ಈಸ್ ದಿಸ್ ಇಸ್ ವರ್ಕಿಂಗ್ ಎಡ್ಜ್. ದಿಸ್ ಇಸ್ ವರ್ಕಿಂಗ್ ಎಡ್ಜ್ ಫಾರ್ ಅಕ್ಯೂಟ್ ಆಂಗಲ್ ಅಟ್ಯಾಚ್ಮೆಂಟ್. ಅಕ್ಯೂಟ್ ಆಂಗಲ್ ಅಟ್ಯಾಚ್ಮೆಂಟ್ ನಾವೇನಾದ್ರು ಅಕ್ಯೂಟ್ ಆಂಗಲ್ ಮೆಷರ್ ಮಾಡಬೇಕಂದ್ರೆ ಲೆಸ್ ದ್ಯಾನ್ 90 ಡಿಗ್ರಿ, less than 90 degree measurement ಮಾಡಬೇಕಂದ್ರೆ we are going to use this attachment. So next one is, this is main body and this is vernier scale. The green color what you are seeing, this is called as what? Vernier scale. And the blue color reading what you are going to see, this is called as what? Main scale. Main scale is on blue color and vernier scale is on green color. You can observe that one. So this is turret to rotate the vernier scale. Vernier scale ಏನಾಗುತ್ತೆ rotate ಆಗುತ್ತೆ. Main scale ಏನಾಗುತ್ತೆ fix ಇರುತ್ತೆ. Okay. So this is the overview of a bevel protractor. So you come over here, you just observe this one. This is the bevel protractor for measuring acute angles. ನೋಡ್ರಿ. So this is adjustable blade. ನೋಡಿದ್ರಿ ಹಿಂದೆ ಮುಂದೆ ಮಾಡಬಹುದು. So you can observe this one. This is vernier scale and this is main scale. So I am showing this one, blue color vernier scale and red color is on main scale. Here also you can observe this one. This is adjustable blade. This is main scale and this is vernier scale. So this is for the measurement of obtuse angles and this is for the measurement of acute angles. See how they are going to measure. This is a figure that is showing that one. I want to measure what is the angle. The angle ಎಷ್ಟಿದೆ ಅಂತ measure ಮಾಡಬೇಕು. So this is adjustable plate. This is adjustable blade. This is what? A working plate. Adjustable working plate. You can observe this one. So this one, this is, or this one, this is working edge, working edge. Both working edges are. This is for acute angle attachment. This is for obtuse angle attachment. So keeping like this, this is main scale. This is vernier scale. So how to measure vernier bevel protractor? ಈ ತರ ಇರುತ್ತೆ ನಮ್ದು vernier bevel protractor. So in bevel protractor, in the main scale, the readings from 0 to 90 degree. There will be a 0 to 90 degree. There are main scale is of round degrees. Circle ತರ ಇರುತ್ತೆ. ಆ ಸರ್ಕಲ್ ನ ಹೆಂಗ್ ಡಿವೈಡ್ ಮಾಡಿರ್ತಾರೆ ಅಂದ್ರೆ, right from 0 to 90, 0 to 90, 0 to 90. There are 4 quadrants. First, second, third, fourth. 0, 10, 20, 30, 40, 50, 90. Again 10, 20, 30, 50, 70, 90. 0, 10, 90, 20, 90. Like that, there are 4 quadrants named from 0 to 90 degree. Main scale division, so 0 ಇಂದ 90 degree ಗೆ ಮಾಡಿರ್ತಾರೆ. Okay. In the vernier scale, there are 24 divisions. You can observe here 1, 2, 3, 4, 5, 6, 7 up to 24 divisions are there. Each side there are 12 divisions. 24ರಲ್ಲಿ ಒಂದು ಕಡೆ 12 divisions ಇರುತ್ತೆ, ಇನ್ನೊಂದು ಕಡೆ 12 divisions. This is zero line. Forget about this line. This is zero line. From 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Like that, this is also zero line. Main scale divisions are in degrees. Main scale divisions are in degrees. ಯಾವ್ದ್ರಾಗಿರ್ತವೆ ಅಂದರೆ ಡಿಗ್ರೀಸ್ ಅಲ್ಲಿ ಇರ್ತವೆ. ಅದೇ ವರ್ನಿಯರ್ ಸ್ಕೇಲ್ ಡಿವಿಷನ್ಸ್ ಯಾವ್ದ್ರಾಗಿರ್ತವೆ ಅಂದರೆ ಮಿನಿಟ್ಸ್. ವರ್ನಿಯರ್ ಸ್ಕೇಲ್ ಡಿವಿಷನ್ಸ್ ಯಾವ್ದ್ರಾಗಿರ್ತವೆ ಮಿನಿಟ್ಸ್ ಇರ್ತವೆ. ಸೊ 0, 30, 60. So they are mentioned in what? 0, 30, 60 minutes. So how many divisions are there in either side? One side ಎಷ್ಟಿದಾವೆ divisions? 12 ಇದಾವೆ. ಟೋಟಲ್ ಎಷ್ಟಿದಾವೆ? 24 divisions. ಒಂದು ಸೈಡ್ ಎಷ್ಟಿದಾವೆ? 12 divisions. ಸೊ 0 ಇಂದ ಈ ಕಡೆ 12, ಈ ಕಡೆ 12. So what is the least count of vernier scale ಅಂತ ಕೇಳಿದ್ರೆ, what is the least count of bevel protractor? Minimum of ಎಷ್ಟು ಡಿಗ್ರಿ ಮೆಜರ್ ಮಾಡ್ಬೋದು ನಾವು? So that is important. Minimum of how many degrees I can measure. So 1 degree is equal to how many minutes? 1 degree is equal to 60 minutes. 1 minute is equal to 60 seconds. Okay, 1 minute is equal to 60 seconds. 1 degree is equal to 60 minutes. So vernier scale reading in bevel protractor, we are going to use. ಡೌಟ್ ಏನಾದ್ರು ಬಂದಿದೆಯಾ ಅದ್ರಾಗೆ? ಹಲೋ ಹಲೋ, ಕೇಳಿಸ್ತಾ ಇದೆಯಾ?
ಎಸ್ ಸರ್, ಕೇಳಿಸ್ತಾ ಇದೆ ಸರ್.
Any doubt in this one bevel protractor? Shall I continue?
ಎಸ್ ಸರ್.
Okay. Next, one more uh, instrument used for the measurement of a protractor, measurement of angle is sine bar. Something has happened over there. Okay, sine bar. Sine bar instrument used to measure angle based on the principle of sine principle. ನಿಮಗೆ ಗೊತ್ತಿರಬಹುದು ಸೈನ್ ಪ್ರಿನ್ಸಿಪಲ್. ಸೈನ್ ಥೀಟಾ ಇಸ್ ಈಕ್ವಲ್ ಟು ವಾಟ್? Sin theta is equal to opposite divided by hypotenuse, isn't it? Opposite divided by hypotenuse. If this is a right angle triangle, this is what? A hypotenuse. This is angle theta, and this is the opposite angle, and this is adjacent angle. If I take sin theta is equal to what? Sin theta is equal to opposite divided by hypotenuse, isn't it? So based upon this principle, I can find out the theta. Theta is nothing but what? Angle. Theta is nothing but what? Angle. So sine bar is based upon this principle. There it's going to be work. Sine bar uses to measure the angle based on the sine principle. Its upper surface forms the hypotenuse of a triangle. So this is the upper surface of a sine bar. You can see this figure. This is the sine bar. Generally, it will be asked for your examination with neat sketch, explain the sine bar. At that time, you want to write this figure. So this is the upper surface. ಈ upper surface ಏನು ಮಾಡುತ್ತೆ? Hypotenuse ಆಗಿ ಫ್ರೇಮ್ ಮಾಡ್ಕೊಂತೀವಿ ನಾವು. Now it is flat. When we want to measure the angle, ಆ ಟೈಮಲ್ಲಿ ನಾವೇನು ಮಾಡ್ತೀವಿ? ಇನ್ಕ್ಲಿನೇಷನ್ ಕೊಡ್ತೀವಿ ಅದಕ್ಕೆ. ಇನ್ಕ್ಲಿನೇಷನ್ ಕೊಟ್ಟಾಗ ಏನಾಗುತ್ತೆ? ಲಿಫ್ಟ್ ಆಗುತ್ತೆ. ಲಿಫ್ಟ್ ಆದಾಗ this surface acts as an hypotenuse. This surface acts as an hypotenuse. Formed by a steel bar terminating in a cylinder near each end. So ಇದೇನು ಮಾಡುತ್ತೆ? ಇದು ಈ ಫೇಸ್ಗೆ ಏನಾಗಿದೆ? ಒಂದು ಸಿಲಿಂಡರ್ ಇದೆ. ಈ ಫೇಸ್ಗೆ ಒಂದು ಏನಿದೆ? ಸಿಲಿಂಡರ್ ಇದೆ. ಸೊ ದಿಸ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ ವಾಟ್? ಎಂಡ್ ಫೇಸ್. ದಿಸ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ ವಾಟ್? ಎಂಡ್ ಫೇಸ್. ನಾನು ಕ್ವಶನ್ ಕೇಳಿದ್ದೀನಿ, ವಾಟ್ ಡು ಯು ಮೀನ್ ಬೈ ಲೈನ್ ಸ್ಟ್ಯಾಂಡರ್ಡ್ಸ್ ಅಂಡ್ ಎಂಡ್ ಸ್ಟ್ಯಾಂಡರ್ಡ್ಸ್? ಲೈನ್ ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಅಂದ್ರೆ ಏನು? ಎಂಡ್ ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಅಂದ್ರೆ ಏನಂತ ಕ್ವಶನ್ ಕೇಳಿದೀನಿ. ನಾಳೆ ಕೇಳ್ತೀನಿ. ಎವ್ರಿ ಒನ್ ಶುಡ್ ಬಿ ರೆಡಿ ಟು ಆನ್ಸರ್ ದಟ್ ಕ್ವಶನ್. ಲೈನ್ ಸ್ಟ್ಯಾಂಡರ್ಡ್ಸ್ ಅಂಡ್ ಎಂಡ್ ಸ್ಟ್ಯಾಂಡರ್ಡ್ಸ್. Here this is called as what? End phase. This is also called as what? End phase. In the end phase there are two cylinders. This is one cylinder and this is one cylinder. So these cylinders are placed on the surface gauge. ಎಲ್ಲಿ ಪ್ಲೇಸ್ ಮಾಡ್ತೀವಿ? ಸರ್ಫೇಸ್ ಗೇಜ್ ಮೇಲೆ ಪ್ಲೇಸ್ ಮಾಡ್ತೀವಿ. Why we are going to place on the surface gauge only? Why not on the ground? Because surface gauge is as much as accurate, ಅಂದ್ರೆ ಒಂದೇ ಪ್ಯಾರಲಲ್ ಸರ್ಫೇಸ್ ಬರುತ್ತೆ. ಬಿಕಾಸ್ this line is almost 100% parallel with the upper surface. ಅಷ್ಟು ಪ್ಯಾರಲಲ್ ಬರುತ್ತೆ. This line is 100% parallel with this surface. That means 0.0001 parallel to this surface. ಆ ಉದ್ದೇಶದಿಂದ ಏನು ಮಾಡ್ತೀವಿ ನಾವು? We are going to place this sine bar on the surface gauge during measurement. So the required angle is obtained when the difference in height between the two rollers is equal to the sine of the angle multiplied by the distance between the centers of the rollers. So generally from this to this distance we know that one. ಇಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ ನಮಗೆ ಏನು ಗೊತ್ತಿರುತ್ತೆ? ಡಿಸ್ಟೆನ್ಸ್ ಗೊತ್ತಿರುತ್ತೆ. Generally this is called as what? L. This distance is known for us. Andre accurate distance. For example, it is 200, 100 or 200 or 300. Like that, the distance is known for us from this cylinder center point to this cylinder center point, and that is called as what? Length between the cylinders. So now, if I take this one, I am going to place the height by using slip gauges. By using slip gauges, I am going to place the slip gauges below the cylinder. Cylinder ಕೆಳಗಡೆ ನಾನು ಏನು ಹೇಳ್ತೀನಿ? ಸ್ಲಿಪ್ ಗೇಜಸ್ ಹೇಳ್ತೀನಿ. ನೋನ್ ಹೈಟ್ ಅದು. H is equal to known for me. H is equal to known for me. How much? H is equal to ಒಂದು 5 mm ನಾನು height ಮಾಡ್ತೀನಿ. One cylinder is placed on the surface gauge and another cylinder is placed on the slip gauge, which is known for me. That height is how much? 5 millimeters. Okay. So now the distance L is also known, H is also known. Now I want to find out this angle theta. This angle theta. So this is the angle we are going to obtain. That is the angle theta. So sin theta is obtained how much? How? Sin theta is equal to, if this is the triangle, this is the hypotenuse, this is the opposite angle, and this is the adjacent angle. And if I want to find out theta, sin theta is equal to h divided by L. So h is the 5 mm, L is the distance from here to here. By using this formula, we are going to calculate theta. Theta is equal to sin inverse of h by L. Like that, we are going to calculate. Sine bars are made up of corrosion resistant material. The sine bars ಯಾವ್ದ್ರಾಗ ಮಾಡಿರ್ತೀವಿ ಅಂದ್ರೆ we are going to made up of a corrosion resistant material ಇಂದ ಮಾಡಿರ್ತೀವಿ. Hardened steel ground and stabilized. The size is specified. Central distance between the cylinder, which is 100 mm, 200 mm and 300 mm. ಎಲ್ಲ ಎಷ್ಟು ಕೊಟ್ಟಿರ್ತೀವಿ? 100 ಕೊಟ್ಟಿರ್ತೀವಿ, 200 ಕೊಟ್ಟಿರ್ತೀವಿ, ಇಲ್ಲ 300. Based upon our requirement, we are going to give that one. The upper surface has a high degree of flatness. This upper surface flatness ಎಷ್ಟಪ್ಪ ಇರುತ್ತೆ ಅಂದ್ರೆ it is an accuracy of 0.001 mm for 100 meter length. ಒಂದು 100 meter length ತಗೊಂಡ್ರೆ ಡಿಸ್ಟೆನ್ಸ್ ಎಲ್ ಡಿಸ್ಟೆನ್ಸ್ 100 meter length ಇತ್ತಂದ್ರೆ ಅಕ್ಯುರಸಿ ಎಷ್ಟಪ್ಪ ಬರುತ್ತೆ ಅಂದ್ರೆ 0.001 mm. ಅಷ್ಟು ಅಕ್ಯುರಸಿನಲ್ಲಿ ನಾವು ಏನು ಮಾಡಿರ್ತೀವಿ, ಸರ್ಫೇಸ್ನ ಪ್ಯಾರಲಲ್ ಮಾಡಿರ್ತೀವಿ. And is perfectly parallel to the axis joining the centers of the two cylinders. So ಇದ್ರ ಸಿಲಿಂಡರ್ಗೂ ಏನಾಗುತ್ತೆ, these are two parallel, ಅಷ್ಟು accuracy ಕೊಟ್ಟಿರ್ತೀವಿ. Now the sine bar by itself is not a complete measuring instrument. Accessories such as surface plate ಬೇಕಾಗುತ್ತೆ, ನಮಗೆ ಸ್ಲಿಪ್ ಗೇಜ್ ಬೇಕಾಗುತ್ತೆ. ಸೊ ಮೆಜರ್ಮೆಂಟ್ ಮಾಡಬೇಕಂದ್ರೆ ಸೈನ್ ಬಾರ್ ಒಂದೇ ಆಗಲ್ಲ. We need surface plate, we need slip gauges. The sign of angle theta formed between the upper surface of sine bar and the surface plate is given by sin theta is equal to h by L. By using this formula, you can calculate the theta. Theta is equal to sin inverse of h by L. So measuring the unknown angles with the sine bar. So this is the procedure. ಇಷ್ಟಂದಾಗ ಹೇಳಿದ್ದೇನು, ಹೆಂಗ್ ಮೆಜರ್ ಮಾಡಬೇಕಂತ ಪ್ರೊಸೀಜರ್. ಈಗ ನಮ್ದು ಯಾವುದೋ ಒಂದು ಇದಿದೆ, ವರ್ಕ್ ಪೀಸ್ ಇದೆ. ಐ ವಾಂಟ್ ಟು ಮೆಜರ್ ದಟ್ ವರ್ಕ್ ಪೀಸ್. ವಾಟ್ ಈಸ್ ದ ಆಂಗಲ್ ಆಫ್ ದಟ್ ವರ್ಕ್ ಪೀಸ್? ಹೆಂಗ್ ಮೆಜರ್ ಮಾಡೋದು? ಸೊ ಟು ಮೆಜರ್ ದಟ್ ವರ್ಕ್ ಪೀಸ್, ಫಸ್ಟ್, ಸೊ ದಿಸ್ ಇಸ್ ದ ಅಪ್ಪರ್ ಸರ್ಫೇಸ್, this is the cylinder, this is one more cylinder, and these are the slip gauges, and this is sine bar. So this is workpiece. This is workpiece. I am going to place the workpiece on the upper surface of the sine bar. On the upper surface of the sine bar ಮೇಲೆ ನಾನು ಪ್ಲೇಸ್ ಮಾಡ್ತೀನಿ. ಪ್ಲೇಸ್ ಮಾಡಿ ಏನು ಮಾಡ್ತೀನಿ ನಾನು, by using dial indicator, I am going to place the dial indicator at the one edge of the workpiece and see the reading. It is showing 0 in the dial indicator. I am going to move the workpiece at the other end also, and I make sure that this is also 0 degree. And so that this surface is parallel to this surface. ಈ ಸರ್ಫೇಸ್ ಯಾವುದು ಪ್ಯಾರಲ್ ಆಗಬೇಕು? ಸರ್ಫೇಸ್ ಗೇಜ್ಗೆ ಪ್ಯಾರಲಲ್ ಇದೆಯಾ ಅಂತ ನಾನು ಚೆಕ್ ಮಾಡ್ಕೋಬೇಕು. ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ಥಿಂಗ್. Then I am going to, based upon that, I am going to place the slip gauges. Like that, I am going to measure the angle theta. In this way, we are going to measure the unknown angle by using a sine bar. The dial gauge fixed to a stand is brought in contact with the top surface of the work part at one end and set to 0. Now the dial indicator move to the other end of work part in a straight line. A 0 reading on the dial indicator indicates that the work part surface is perfectly horizontal and set the angle is in the right one. So in this way, we are going to measure the unknown angle using the sine bar. So there are very much advantages as well as disadvantages in sine bars. It is a precise and accurate angle measuring device. ಪ್ರಿಸೈಸ್ ಆಗಿ ಮೆಜರ್ ಮಾಡ್ಬೋದು, ಅಕ್ಯುರೇಟ್ ಆಗಿ ಮೆಜರ್ ಮಾಡ್ಬೋದು. ಕಂಪೇರ್ ಟು ಬಿವೆಲ್ ಪ್ರೊಟ್ರಾಕ್ಟರ್ಗಿಂತ ಅಕ್ಯುರೇಟ್ ಆಗಿ ಮಾಡ್ಬೋದು ಇದರಲ್ಲಿ. ಇಟ್ ಈಸ್ ಸಿಂಪಲ್ ಇನ್ ಡಿಸೈನ್ ಅಂಡ್ ಕನ್ಸ್ಟ್ರಕ್ಷನ್ಸ್. ಇಟ್ ಈಸ್ ಈಸಿಲಿ ಅವೈಲಬಲ್. ಬಟ್ ಡಿಸ್ಅಡ್ವಾಂಟೇಜಸ್ ನೋಡ್ರಿ, it can fairly give good results when the angle is less than 15 degree. 15 degree ಗಿಂತ ಕಡಿಮೆ ಇದ್ರೆ good results. We are going to get good results. We are going to get good results when the angle is less than 50 degree. If it is more than 45 degree, not suitable. Not suitable. Errors ಜಾಸ್ತಿ ಬರುತ್ತೆ ಯಾವಾಗ, when it is more than 45 degree. It is difficult to handle and position the slip gauges. ಯಾಕೆಂದ್ರೆ ಇಲ್ಲಿ ಸ್ಲಿಪ್ ಗೇಜ್ ಇಡಬೇಕು, ಒಂದ್ ಕಡೆ ಸಿಲಿಂಡರ್ ಏನು ಇಡಬೇಕು, ಸ್ಲಿಪ್ ಗೇಜ್ ಇಡಬೇಕು. ಒಂದ್ ಕಡೆದು ಸರ್ಫೇಸ್ ಗೇಜ್ ಮೇಲೆ ಇರುತ್ತೆ, ಇನ್ನೊಂದು ಸ್ಲಿಪ್ ಗೇಜ್ ಮೇಲೆ ಇರುತ್ತೆ. ಇಟ್ ಇಸ್ ಡಿಫಿಕಲ್ಟ್. ಇಟ್ ಇಸ್ ನಾಟ್ ಅನ್ ಈಸಿ ಮೆಥಡ್ ಟು ಸ್ಲಿಪ್ ಗೇಜ್ ಇಡೋದು, ಅದ್ರ ಮೇಲೆ ಸಿಲಿಂಡರ್ ಇಡೋದು. ಇಟ್ಸ್ ನಾಟ್ ಅನ್ ಈಸಿ ಟಾಸ್ಕ್. ದ ಸೈನ್ ಬಾರ್ ಇಸ್ ಫಿಸಿಕಲಿ ಕ್ಲಮ್ಸಿ ಟು ಹೋಲ್ಡ್ ಇನ್ ಪೊಸಿಷನ್. ಸ್ವಲ್ಪ ಹೆವಿ ಇರುತ್ತೆ. ಇಟ್ ಇಸ್ ನಾಟ್ ಈಸಿ ಟು ಹೋಲ್ಡ್ ಅಂಡ್ ಪೊಸಿಷನ್. The application is limited for a fixed center distance between two rollers. That is important. If I take the distance is 100 mm, then it is limited to 100 mm. If it's take the 200 mm length sign bar, it is limited to 200 mm. I can't measure the long workpieces or the angles. Slight errors of the sign bar cause large angular errors. So very important thing, slight error of the sign bar. This is the sign bar. Very much error. This itself is error. If this itself is error, then the result will be indicating in the long angular errors. So these are the advantages and disadvantages of sign bars. So we'll end up today. Thank you. If you have any doubt,